Today we're gonna solve the problem 142, linked list cycle 2. So this is a deeper version of the LeetCode 141. So given the head of the linked list, return the node where the cycle begins. If there is no cycle, return now. There is a cycle in linked list if there is some node in the list that can be reached again by continuously following the next pointer. Eternally pose is used to denote the index of the node that tells next pointer is connected to. It's -1 if there is no cycle. Note that pose is not passed as parameter. So for this problem, we're gonna return the node where the cycle begins. So I think it's hard to just imagine. We will just draw a picture, draw a cycle here. So A is from the start to pose, the distance, the number of nodes, and B is the number of nodes in the cycle. So we got two equations about fast and slow. So fast is equal to 2 times slow, which is obviously since when slow moves 1 step, the fast will move 2 steps. And fast is also equal to slow plus n times b, because obviously when they meet at the same distance, it will equal to s plus n times b. B is the number of nodes in the cycle. So according to these two equations, we get that fast is equal to 2 times n times b, and s is equal to n times b. So for pose, it equal to a plus n times b, and therefore we know that slow is already equal to n times b. If it wants to reach the pose, it will still need to move a distance. So therefore, actually from the node that they move to pose, the distance is equal to from the start to pose, which is a. So after we get this conclusion, it's very easy for us to write the actual code. So let's look at our code. So basically the while loop makes sure that they will meet after that, and after they meet, we will move one pointer to the start point of the linked list, and we'll let another pointer move from the point they meet. So they will move in same speed, and eventually they will be at the same point, which is the node where the cycle begins. And the time complexity of this code is big O for n, where n is the number of nodes in the linked list. So the reason for this is because in the first part of the node, the loop, the 2 pointers move through the linked list, so the fast pointer moves twice as fast as slow pointer. If there is no cycle in the linked list, the fast pointer will reach the end of the list after going through all the nodes, which takes big O of n time. So actually it will take big O of n over 2 time, but actually since it's big O notation, we will drop the constant factor, so it simplifies to big O of n. And if there is a cycle in the linked list, the 2 pointers will eventually meet within the cycle, which also takes big O of n time in the worst case, as it depends on the number of nodes in the list. So after detecting the cycle, the code resize one of the pointers to the head of the list and moves both pointers at the same pace until they meet at the starting node of the cycle. This last part also takes big of n time in the worst case, so therefore the overall time complexity is big of n.